Assalamu alaikum students. Now we will be solving one problem related to electric field. Here everything here is a given. I have two electric charges Q1 and Q2. Q1 of magnitude 5 microcoulomb and Q2 is of magnitude negative 5 microcoulomb, so it is a negative charge. Q1 is placed at the origin. Okay, as you can see, this is the x-axis and this is the y-axis, while Q2 is placed 0.45 meters away from Q1. The problem is to find the electric field at the point P. As you can see, P is along the y-axis and it is 0.3 meters above the charge Q1. So I'm interested in the electric field E at some location in space, at the location or the point P. As you know that the electric field here will be due to the two charges, Q1 and Q2. Actually, the electric field here will be a combination between E1 from Q1 and E2 from Q2. To know where will the electric field point, let us assume that we have here a small tiny positive test charge at this location. If I place here a tiny Q which is positive, what will happen to it because of Q1? Since both are positive, then it will be repelled, and this is how I know the direction of E1. And if I place here a positive test charge, it will be attracted to Q2 since Q2 is negative. So E2 will be pointing toward Q2. To find the total electric field at P, I need to calculate E1 and E2 separately first. Let me calculate E1 and E2, then add them as vectors for sure to find E total. So in this part of the video, we will be calculating E1 and E2. The formula for electric field, E equals K, Q causing the field, divided by R squared. So for E1, it will be using this formula 9 times 10 to the power of 9 times the Q1, which is 5 times 10 to the power of negative 6 to convert from microcoulomb to coulomb, divided by the separation between the point and the charge, so 0.3 meters squared. Using our calculators to find this number, we will find that E1 equals 5 times 10 to the power of 5 Newton per coulomb. Please, you can stop the video and try it yourself. While E2 will be equal to K, which is the Coulomb's constant, 9 times 10 to the power of 9, times the charge Q2. I am talking here about the magnitude, so I can just ignore the negative sign because I need the magnitude of this vector, divided by R squared. R squared is the distance or the separation between the point and the charge. So actually, it is this distance R, and it is not given for me, so I need to stop a little and go to find R. R is the hypotenuse of this right triangle, so simply I can apply, so R2, let me name it, I can apply the Pythagorean theorem to find it. It's the square root of 0.3 squared plus 0.45 squared. Applying this, we will find that this distance is actually 0.541 meters. And then I can substitute it here. Plugging all this on the calculator, I find that E2 is equal to 1.54 times 10 to the power of 5 Newton per coulomb. So in this part, the first step, I found E1 and E2, the magnitudes of them. we will do the next step in the next video.